Hi everyone. I hope you're all having a great Monday. And we're just going to touch on a couple of things that we didn't get to yet from section 3.3. I know we did talk about this, but the emphasis, of course, is always on the importance of why we need a common denominator and what sort of representations we can use for that to make adding and subtracting fractions easier for our students. And as always, it is important that we understand a multitude of ways to show it in case someone didn't understand the first or the second or the third explanation that you gave and you need to come up with something else. A little bit we're going to start with today, addition of fractions. And we're going to use Cuisenaire rods to do the problem 1/2 plus 1/3. And you may remember, especially when you see the pictures here in the next slide, that the Cuisenaire rods are those sort of like a long rod, and they have different colors on them, and then they have different sizes. So one of many different solutions is if we would say the dark green rod has a value of 1, like in this picture. So if we say that the dark green has a value of 1, and then we have 3 of these smaller red ones, each of those is a third, and then 2 of these light green ones so that each portion of the light green one is 1/2. Sorry, and going to the next slide. So if you put a 1/3 together with a 1/3 together with a 1/2, and then you can see that it's smaller than a whole one. So you could also then get out these smaller white cubes, and I think I showed you those when I gave the demonstration of the Cuisenaire rods. And then that would tell you I need 5 of these little smaller parts. And each of those would be a 1/6, because I would need 6 of these to be as long as the green one, the long green one. So 1/2 and 1/3 must equal 5/6. Cuisenaire rods can also be used to introduce the concept of LCM, which we started talking about on Thursday or Wednesday, I guess it was. And here's an example of how to use that to help students understand the concept of LCM. So if they wanted to see what the least common multiple of 4 and 6 was, here's 3 different arrangements for 4 and 6 rods. Well, the smallest one is this one over here on the left that has 3 4s and 2 6. So that would indicate that the LCM is 12, because that is the shortest combination of a train that we can get that matches. So that would give you your least common multiple would be 12. And we're going to talk about some more concepts and connections. We're going to now look at a general procedure for adding fractions using this addition problem below, and justify each step using area models, linear models, and a set model. And I know we already talked about the set models on Wednesday, so we're going to just do the linear models and set model, or area models and linear models today. Here is an area model to represent 2/3 plus 1/4. And because the pieces are not the same size, we need to make them the same size. Young students can figure this out by placing pieces on top of the thirds and fourths and learning that the 12ths will fit into both of them, like this. And they can also use the fact that the least common multiple of 3 and 4 is 12 to turn their drawing into 12s that make the parts addable, so that we are adding the same size pieces. Here's a bar model, or a linear bar model, to show a similar kind of concept. So here we're doing 2/3 and 1/4. So here are 2/3 and here is 1/4. And you can see that you have to split it into 12 sections. And then since 12 is the least common multiple. And then if you stack them all up alongside each other, then you see that you get 11 12ths. We begin with one bar representing the unit, create thirds, and mark 2 of the thirds. Then we draw a bar of the same size and mark 1/4. Again, we have to create the same length bars and to be able to add them. So we show that 2/3 is equal to 8 12ths, 1/4 is equal to 3 12ths, and the third bar is where we actually put the two pieces together to get 11 12ths. That is just a summary of what we just did. Here's, and another set model. I left this one in here because it was different than the one that we did in class. So this is another way to do 2/3 and 1/4. So here is 2/3 and here is 1/4. And then we put the two together and we get 11, because there's 4 on that top, 4 on the next one, and 3. So we get 11, so it is 11 12ths. I forgot that this other set model was in here. So some of these procedures are easier for students to understand and remember when they have these visual models to give meaning to the procedures, and all of them, though, are encompass that same concept of finding a common denominator so that all parts are the same size, and then we add the pieces. And we're going to talk about subtraction. So subtraction of fractions involves essentially the same process as does addition. However, many students encounter difficulty in situations that involve regrouping, as we know. So we're going to consider this problem here, 23 and 2/5 minus 17 and 4/5. And then first do it on your own. And then we're going to discuss it. Okay, so we're going to talk about why they did 23 and 2/5 to 20, changed it to 22 and 7/5, and how you would explain that to someone who does not understand it. One explanation might be that we must do some trading, just like in whole number subtraction, because we cannot subtract 4/5 from 2/5. With fractions, instead of trading 1 10 for 10 ones, as we did with the whole number subtraction, we are now trading 1 unit for 5/5, or 6 6, or 10 tenths, depending on the common denominator. Expanded form will help to illustrate this process and justify the equivalence of 23 and 2/5 to 22 and 7/5. So 23 and 2/5 is equal to 23 plus 2/5, which is then equal to 22 plus 1 plus 2/5, which is then equal to 22 plus 5/5 plus 2/5, and that is 22 and 7/5. And then that, arranging your problem that way is going to be a little bit easier than what a lot of people will do, which is changing the mixed numbers to improper fractions and then doing the subtraction that way. Because you notice that they both do have that common denominator of 5, so that's not a problem. The problem we had was that you can't do 4/5 minus from 2/5. And so that was where we had the problem. It wasn't a problem related to common denominators. So the issue is with this, doing it this way, if you change it to an improper fraction, then you end up with an improper fraction, and then you might have to change it back to a mixed number. Because there are so many strategies used in mental addition and subtraction of fractions, we will examine them using a process similar to the one we use when developing mental math strategies with whole numbers. In each of the following problems, try to find the sum or the difference entirely in your head and briefly describe your strategies. So here's some problems we're going to do without hopefully having to write too much down. Keep the following points in mind for each problem. Deciding which strategy is best is often not as helpful as knowing which strategy works best for you. Learning a variety of strategies will help you find strategies that work for you and that will work for your future students. Not all possible useful strategies have been included here because too many strategies and a 1,500-page textbook can overwhelm students. So we're going to try this one, 2.5 plus 5 3/4. One way of doing this would be to use the commutative and associative properties. So breaking that 2.5 out into two parts using associative properties, and then regrouping and putting the 2 with the 5 and the 1/2 with the 3/4. Because the 2 and the 5 would give you 7, and the 1/2 and 3/4 would be decomposed into 1/2 plus another 1/2 plus another 1/4. So that would give you 8 1/4. One idea. Then here's a different way of doing it. So strategy 2, lost my pointer, 2.5 plus 5 plus 3/4. So split it into, put the 2 and the 5 together into a 7, and then put the 7 with the 1/2, and then have the 3/4 separately, so that it is 7.5 plus a 1/2 plus another 1/4, and then that gives you 8 1/4. If you combine the 7.5 and the 1/2 separately, and then add the 1/4 on the end, and then that gives you 8 1/4. Problem B is 7 3/4 plus 5 1/8. And you can add 3/4 and 1/2 mentally, maybe, to get 1 1/4, and then add 1 1/4 to 1/8, and finally 1 2/8 plus another 1/8 will give you 1 3/8. And then add this to 14, and we get 15 3/8. And the 14 came from doing the 7 and the 5 and the 2. separately. And that means 11/8, which is 8/8, which equals 1 plus 3/8. And then you add that to the 14 to get 15 3/8 as your answer. Problem C is 7 minus 2 5/8. One strategy would be to do the 7 minus 2 part first and get 5, and then take 5/8 from 5 to get 4 3/8, knowing that you need 8/8 to get a whole. Another strategy would be to add up. So to start at the 2 5/8, and then maybe add 4 to get to 6 5/8. And then you would need to figure out how much more you need to get to 7. And that would mean you would need to add 3/8 more. And so your answer would be 4 3/8. And then this is problem D, 9 1/4 minus 3 5/8. And for this one strategy is to add up again. So start at 3 5/8 and add 5 to get to 8 5/8, and then another 3/8 to get to 9, and then another 2/8 to get to 9 1/4, since 2/8 is equal to 1/4. What you have to remember to add now is 5 plus 3/8 plus 2/8 equals 5 5/8. A number line definitely helps some students to understand the process better. Oh gosh, I see I have a crazy hair going on here. Okay. And then here's a problem. It rained almost every day this past week. Here are the amounts per day. How much rain fell during the week? First, make a rough estimate, then make a refined estimate. Strategy 1, make a rough estimate. One way to get a rough estimate is to round each fraction to the nearest half inch and keep a commutative total. So 2 1/2 rounds to 3. 3 plus 1 is 4. 4 plus 4 equals 8, and 8 plus 1 1/2 gives you 9 1/2. Another strategy is to look for compatible numbers. One way to get a closer estimate is to look for compatible numbers, or numbers whose sum is close to 1, or numbers that you can quickly add mentally. And I know we talked about this quite a bit with our whole numbers. So you might notice that 3/4 and 3/4, if you add the 1 and the 3, you get 4, and then 3/4 and 1/4 would give you another 1, making that a 5, and then the 2 1/4 would give you a 1/2. And then separate the other half that you had as another one of your data points. And then 5/8 and 1 5/16 is about 2. And then about 1 for the 7/8, giving you a rough answer of about 9. Okay, this is what I have for today, and then I will see you guys for a similar video tomorrow, and we will start section 3.4, and I hope everybody's doing good. Email me if you need anything, and I'll talk to everyone soon. Bye-bye.